All right. Hi, Christina. It's nice to finally see you. I always see you commenting and stuff. Good evening. I hope everything's good with you so far. So I'm gonna probably another minute. Probably another minute or two, and then we're gonna start. And then oh, I should definitely like put the put the what we're doing here in the chat. Let me see if I can get it. Hey Z, hi, what's up? Alright, it's good to see you. It's good to see you. Or hear you. Or yeah, to see you. Okay, right. Alright. What am I looking? Oh, yeah, see I found it here. So let me get the link. It's kinda like a collection of CXC past papers, really. Stuff that you can use like afterwards. So oh oops. Let me see if I can just get them to you so you can use them. Just give me a minute. Or you know what? I'll just put it in the chat after we're finished. You guys can kind of just follow along as we go along. See? So it's good to see the persons who are here, and let's see if we can do some practice with functions today. All right. So that's what we're working on. So I want to see what we can do with functions. I'm kind of going to try and start with what you guys know, and then we're going to try and build from there. This is the first live I've ever done on this too, so I hope everything works out. I don't really know how it goes. I'm just trying a thing. So if it's anything go wrong, just let me know so I can fix it. But yeah, I'm just try a thing still. So let's see. So the first thing that I want you guys to do, because we just want to work through some papers, I'm assuming you guys know a little bit about functions, but I don't want to just assume. So let me know in the chat. On a scale of 1 to 10, rate yourself on how good you are at functions. Where would you put yourself? Would you say you're a 10, like you know it, you got it? Would you say you're a 5, like kinda, not really? Or would you say you're at 0, like nothing, I don't know nothing at all? So put it in the chat, let me see. Where you rate yourself. So on a scale from 0 to 10, where you put yourself? How much you say? Tell us a 2, no problem. Let me see. Nick's Keel said 6, so we have some 2, 6, 4. Christina saying 3, Z saying 4. Like you kind of have an idea, but you don't really remember. I guess it's kind of like those. All right, no prob, no prob. Musical melody says 3. All right, so we kind of have. I think we're kind of on that end. No prob. So let's see what we can do. So that means we're gonna have to just review some of like the key ideas behind it, some of the stuff that we definitely need to know, and then we're gonna go into some of the practice questions. So first, let's start with this kind of helps us to get the idea of what a function is. So I want you to look at this table And I want you to tell me if you can figure out, based on the pattern, what number should go at this first question sign. Tell me what you think. So what number should go there, so? What are you guys thinking? All right, I see Nick saying 3. And let's try it out. Let's see. So we notice here each time it's adding by 3. So 10 plus 3 is 13, 5 plus 3 is 8, 3 plus 3 is 6. So yeah, the number that would be here would be 3. All right, good. So you kind of have an idea of what a rule is, okay? What about this table? Can you figure out the rule in this table? Think you see a rule, or if you're not seeing a rule, say, no, I'm not seeing any rule. What are you thinking? Or if you see one, you say, yeah, that's the rule. This one take a little thinking, doesn't it? Let's look at it good. I think there's a rule there. Well, this rule is it's kind of interesting. It's kind of interesting for this one. Because if you look at it, if you look at what we have in and what we get out, in the first one, we get out A. The second, we get out A. The third one, we get out O. So you notice it's basically like the second vowel. Can I see that? Because the second vowel here is A. Over here, the second vowel is A. Over here, the third vowel is... the second vowel is O. I wonder if you guys seen that rule. So the rule is that you put in the value, you put in the word, and it gives you the second vowel. That would be the output. Yeah. Oh, Z, you're saying you see it. Nix is saying they're looking for the vowels. Yeah, that's it. You're taking out the second vowel for each. So that's the idea here, and that would be our rule. The output is the second vowel. So this kind of gives you an idea of how a function works. A function works in the same way. As a matter of fact, all of those stuff were functions. You put something in, and then you get something out. You understand? So once you're able to figure that one out, then you'll see it. Oh, Christina, you see it now? yeah, that's it. That was it. So when we're talking about functions, okay, for CXC, we cover just like, there are 3 main ideas that we cover for functions, especially on paper 2, right? And those 3 main ideas, those 3 skills that we have to have, is that you have to be able to evaluate functions, Zine. You have to be able to find composite functions, and you have to be able to find inverse functions. So those are the 3, I'd say, the 3 main ideas when we're talking about CXC functions, especially on the paper 2. Now, if you watch the video that I uploaded on the 5 topics you need to know functions is one of them. And the reason why I put it there is because you kind of see it every year, and it kind of looks the same because there are umbrella ideas that once you have the idea, then you'll be able to do them. And the reason I put it here is that once you're pretty good with algebra, then you'll be able to do functions. Seeing in the chat, Janelle, yes, I'm going to save this. I'm going to save this live. I want to, for everybody to see afterwards. So these are the 3 main ideas. So I want you guys to get that in your head. These 3 things we definitely need to know how to do. To evaluate a function, so you guys say you rate yourself at 3s or 4s. So then let's see if we can make sure. I want to check if you guys are able to do this. Evaluate functions. So that just means we're putting an input, just like with the table before. We put in a value and we get out a value. So for example, if we had a function, let me write that down at the bottom. If we had a function that was equal to, that is f of x is equal to 2x minus 1, then what would f of 3 be? A problem like that is what we mean when we say evaluating functions. Before I look at it, I want to see if you guys can do this one. So could you tell me what f of 3 is? Could you write it in the chat? What f of 3 would be? What do you think? So let me see if you are able to do this one. If you don't remember how to do this one, then that's fine. Just say IDK or so. Okay, oh great. So you guys can do it. Alright, good. So I'm seeing that from Nix and Christina. So yeah, f of 3 would be 2 times 3 minus 1, 6 minus 1, which is 5. Okay, great. So you guys can do that one. So once you know to do that, some marks that on CSEC. You start already. Now, what about composite functions? Let me test if you guys are able to do that one. Now, a composite function, it's just like evaluating functions, but you're putting one function into another. So you see, like with the one before, we put a value into the function. This is different because we're putting one of the functions into another function. So let me show you what I mean. For example, let's say that I had a function f of x being equal to 3x plus 1 and g of x being equal to, I should have color coded this, g of x being equal to x squared, right? Then if I have a function f of g of x, what it means is that I'm putting g of x into f. So I'm taking this function, g of x, and I'm putting it back into f. So that's literally what it means. It means putting g of x. So you're putting g of x into function f. See? So that's what that means. So whatever g of x is, we're going to put it into the function. So anywhere we see the input for f, instead of writing back x, we're going to write whatever g of x is. So since g of x is x squared, instead of writing 3x plus 1, we would write 3x squared plus 1. That's how we put g into f. You guys ever seen anything like that before? Is that jogging your memory a little bit? Or was this one of those things you felt like you had problems with? What do you think? Okay, so you kind of remember this a little. That's good, that's good. Seeing Christina saying, yeah. Oh, Nix is saying, saw it before, okay with it. I've seen it before. All right, great, good. So that means you guys kind of have a head start. Z, you remember it. All right, good. So that's one thing we know too. So, and we'll be doing some more like it while we're working those questions. And then finally, let's talk about inverse functions. Now, no, this is the one that sometimes gives students a little trouble, yeah? But what an inverse function is, it's basically like this big undo button. So you're undoing the function, right? So if the function says, so let us say that the function was 2x. What does this function mean? To multiply by 2. So what does its inverse mean? What is the opposite? Or how do you reverse multiplying by 2? Uh, I don't know if you guys are able to see me still. Computer fail me. I knew that this was gonna happen. That's why I don't. That's why I don't usually like the live video. I'm gonna forget that. I'm gonna forget a different computer I change out or something. Sorry about that, everybody. Hopefully we're on our way still. But if anything else happen and I drop off again, you don't know. You don't know what happened. So hopefully that doesn't happen again. But yeah. All right, good. Yeah. So what I was saying was that when we're talking about the inverse, let me just kind of get my thing up here. When we're talking about the inverse, we know we're talking about functions that would trying to get my, looks like I'm having a little problem again. Give me a minute. No, it's not your internet, Christine. I don't know. We need to switch out. Just give me 1 minute. Soon come again. All right, everybody. Sorry about that. Yeah, it's not you. It's me. It's not you. It's me. Sorry. Yeah. So we're talking about the inverse function. What we were saying is that if the function said that we were multiplying by 2, then the inverse of the function would be to divide by 2. Okay? So that's what we mean when we say the inverse. It just does the opposite of whatever it was supposed to do. Like if the function said, okay, we're going to add 1, then what do you think the inverse of that function would be? What do you think the inverse of that function would be? If you're adding 1. Yeah, that's right. Yes, that's right. The inverse would be to subtract 1. So that means our inverse here would be to subtract 1. So that's the whole idea behind the inverse. But the only thing is that when the inverse gets a little bit more complicated, then it requires us to do a little bit more. See? But basically, anytime you're finding the inverse of a function, it's the same thing as changing the subject. That's the whole idea behind the inverse function. Yeah? So if you were to find the inverse function of something, you're just going to basically change the subject. But we can do it in 3 steps to make it a little easier. That basically, to find the inverse, first we let y be equal to f of x, right? Next, we solve for x in the equation, and then finally we rename x as f inverse x, and we rename and swap the y's for x's. And that's it. That's basically how we find an inverse function. Yeah? So that's all we do. All we need to do is those three things, and then we'll be good. Okay? Now, of course, it's then important. We're going to see how we can do it for a few, but let me give you one to try just before we go on to some past paper ones. So let me see if you can apply that to find the inverse of, let's say, p of x being equal to 2x plus 1. What do you think the inverse of that function is going to be? 2x plus 1. How would you find the inverse? And then the thing is, you can find the inverse in a lot of different ways. So whichever way you find it is fine. This is just one of those ways. So how would you find the inverse of that function? All right, so I'm seeing some responses in the chat. So let's see if we can figure it out. So the inverse of the function, 2x plus 1. Okay, so now let's think about it. First, we're gonna solve for x. That's the idea behind it. So let's take p of x being equal to 2x plus 1. So we're going to treat, because it's kind of confusing to be writing back p of x, p of x, p of x all over the place. So that's why we let it equal to y. So if we let y be equal to p of x, then that means y is going to be equal to 2x plus 1. Now, if we solving for x, then what's going to happen? Well, if y is equal to 2x plus 1, that means y minus 1 will be equal to 2x because we subtract 1 from both sides. Okay? And then how can we get x by itself? Well, we can divide both sides by 2. So if I divide this side by 2 and this side by 2, now I'm going to get x being equal to y minus 1 divided by 2. Now that I've solved for x, I'm going to change out the notation, rename the stuff, so it's kind of easier for us to recognize that it's the inverse. So therefore, we would say that f inverse x, which is what this now represents, is equal to x minus 1 divided by 2. So we've made the input the new output. All right? So we just solve for x and then change out the notation, and that's how we find the inverse. Let me know if that is clear. Give me a thumbs up if that's good, or a thumbs down if you're still kind of like, not really sure about that one. Let me see what you guys are thinking. Let me see if I can help you in any other way. Because those are the three main stuff that you're gonna kind of have to. We want to make sure that we get good for functions. But then I'm seeing some of you guys have it in the chat still. I'm kind of seeing you guys having some of this stuff in the chat. Kinda. I see what you're saying, Christina. Kinda. And we're gonna cover a few. Alright, musical is saying you're good to go. Alright. Not leaving anybody behind. So I just want to make sure we're all there. Z, what you say? You're good? It's good for you so far, or not really, or is it up or down? Okay. All right. Awesome. Awesome. So, you know what this means, guys? I think this means we can start looking at some CXC problems. So I have about 4. Zin. Remember I was telling you inverse functions is like a big undo button. It's kind of it. It's like you just do the reverse or the complete opposite. Anyways, I like that meme. That's a pretty cool meme. Math jokes are fun, right? Yeah, no? Let's go to our first question. Zin. And in this question, we are gonna be looking at a past paper question. I think this is the May-June question for 2021. Yeah. Z, did you just say math jokes are not cool? Feel that. Oh, you're joking. You're better. Okay. All right, let's jump into this question. So typically on the exam, you're going to find most functions questions like 4 or 5 marks, you know. Sometimes they're like a half of a question. Recently I saw one that was an entire question, so that happens too. You know, nothing is wrong with that. So this is one of them. This was on the January 2021. I don't remember which exact question it was, but it was about half of the question. So let's give it a try together. So it says, given that the function f of x is equal to a third of x plus 4 and g of x is equal to 3x divided by x plus 1, first we want to determine the value of f of 9, calculate the value of f of g of negative 3, and determine the value of x for which g of x is equal to 5/2. So let's start with the first one. Determine the value of f of 9. So what do we already know? We know that f of x is a third of x. So that means f of 9 then is going to be a third of 9. Because anywhere we see x, now we're going to replace it with the new input 9. So that's a third of 9 plus 4. What's a third of 9? A third of 9 is 3, because 3 into 3 is 1. 3 into 9 is 3. So this is going to be 3 plus 4. And 3 plus 4 is 7. So f of 9 is equal to 7. In other words, we put 9 into the function, we're going to get out 7. Alright? So that would be that would be f of 9. Now let's see if we can work out f of g of negative 3 together. Okay? So f of g of negative 3. So this is a composite function, and anytime you're thinking about a composite function, it's always good to ask yourself, what does it mean? Like, what does it really mean? Because that's what's going to help you to understand what or how to figure out what to do. So what does f of g of negative 3 mean? You're putting one function into the other. So it basically means that you're putting g of negative 3. Let me zoom in a little. Alright. It means that you're putting, basically what it's saying is f of g of negative 3. So you're putting g of negative 3 into the function. You can kind of read it like this. So anything you have here, you're putting this into this. So it's literally saying put g of negative 3 into f. What do you guys think about that? Everybody is clear on why f of g of negative 3 means that? Means putting g of negative 3 into f? Thumbs up if you're clear. Let me know if you understand what that means. Or if not, so we can kind of try make sure that you understand. Okay. All right. Great. So I think you guys get it. So what does that? What are we gonna do? If we're putting g of negative 3 into f, it means we're going to have to find g of negative 3 first. So let's do that. So g of negative 3, well, we need to first remind ourselves, what was the function g again? Well, g was 3x over x plus 1. So g of negative 3 is going to be 3 times negative 3 over negative 3 plus 1. 3 times negative 3 is negative 9. And negative 3 plus 1, that's negative 2. Because you owe 3 and you get 1, so now you owe 2, or it's negative 2. So g of negative 3 is negative 9 divided by negative 2, and we can kind of simplify that because we know negative divided by negative is a positive, so it's really just 9 halves. 9 divided by 2. Okay? Now that we know g of negative 3, we are going to put it into f. Now that we know what it is. So that means f of g of negative 3 is going to be equal to the same thing as f of 9 halves. So we're putting 9 halves into f. What is f again? F was a third of x plus 4. So that's going to be, instead of a third of x, it's going to be a third of 9 halves plus 4. Right? And let's see if we can do some simplifying here. 3 into 3 is 1. I wish that thing was a little bright. Oh, it's kind of fine. Yeah, this is a little brighter. 3 into 3 is 1. 3 into 9 is 3. And let's simplify it now. 1 times 3, that's 3. Down here, 1 times 2, that's 2. So that's 3 halves plus 4. But guess what? We know that 3 halves is 1.5. So it's really just 1.5 plus 4. And 1.5 plus 4 is 5.5. So f of g of negative 3 is equal to 5.5. Yeah? So that's the output for our input. Yeah? You notice it says 2 marks. CSEC is giving you 2 marks for this. They give you 1 mark for correctly finding g of negative 3, and then another mark for putting it into f. Another way that you could have done it is to find f of g and then put negative 3 into it. So you could find the composite and put it in. But, you know, I kind of did it this way because once you're working with the number, it's a little easier to work with. And those 2 functions kind of look, they looked a little complicated. So can't bother with that. We'll just work it out and put it into it. Alright, so we found f of g of negative 3. Now let's go to the last one. Determine the value of x for which g of x is equal to 5 halves. Let's make sense of what does all of this mean. So think about it, right? We are saying we want to find x. X for what? Find the value of x for which g of x is equal to 5 halves. See? What do we know about g of x? I keep forgetting what the functions are, but we know that g of x is 3x divided by x plus 1. So if g of x is equal to 5 halves, that's basically saying that 3x divided by x plus 1 is equal to 5 halves. Follow me? Everybody's with me so far? So now, essentially what we have, because we want to find x, we don't know the input. We don't know the input. This is what we do not know. But we know the output. we know that our output is 5/2. So now we're just trying to figure out how we can use this to find the input. So let's see how we can do that. So it's basically, here we want to solve for x, right? And, well, you know, we can kind of get rid of the fractions. So we can multiply, we can do a little cross multiplying here. So that's basically 2, oh, let me use that in blue stills. 2 times 3x is equal to 5 times x plus 1, zine. And what do we know? 2 times 3x is 6x. 5 times x, so remember we're multiplying this term across the whole bracket. So that's 5 times x, which is 5x, and 5 times 1, which is 5. Now, we need to solve for x, so we can put all the x's on one side. Yeah? So I can move, technically, move the 5x over here. So now because it was adding, now it's going to be subtracting. So 6x minus 5x is going to be equal to 5. Since 6x minus 5x is 5, 6x minus 5x is just x. So that means x is equal to 5. Okay? So that's the value of x for which g of x is equal to 5/2. So to sum up, we didn't know the input, but we knew the output and we used it to help us solve. So talk to me, guys. How we feeling so far? We following everything so far? Are we see for number 3 why x is equal to 5? Is there any questions that you have about it? Anything that you're wondering? Usually, like, or I didn't even remember that YouTube doesn't you can't talk, so you kind of just have to type, because usually I want to hear from you if there's something that you don't understand or if you're good with everything. So I guess we just have to work with the chat for now, you know what I mean? So always stay. Always stay. Oh, questions. All right. Everybody else feel the same? Good? All right, Christina, tell me from where? Can I write it? Which from which one? From number 1, number 2, or number 3? Oh, see, you keep reaching. Yeah, I know, right? I mean, yeah, that's how we used to, where you're talking and stuff. But Christina, tell me where you're feeling your problem is. And then we just go back there. Oh, this last one. Okay. All right. So let me go over here. Let's kind of break it down. Because what we want to know is, we want to use what we know to figure out what we don't know. Cool? So we want to find the value of x for which g of x is equal to 5/2. What does that mean? What does it really mean? It means that we don't know x, but we know the output. The output is 5/2. Cool? So we know that if g of x is 5/2, 5/2, then that means 3x over x plus 1 is equal to 5/2. Oh, you're saying at the last part. All right, let me number the lines. So this is line 1, 2, 3, 4, 5. Which one of them? Line 1, 2, 3, 4, or 5? Line 4. Okay. 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 All right, let me rub it out. So 6x is equal to 5x plus 5, right? So we want to figure out what x is. In order to solve for x, we have to group the like terms together. So 5x is like 6x. So we need to get 5x to the other side of the equation. So here's one way to think about it. To get 5x to the other side, I could carry it over, right? But because it was adding here, because it's positive, not positive, because it's adding, then when you carry it over here, it's going to be subtracting. In other words, to get rid of the 5x, I could subtract by 5x on this side, but I'll also have to subtract by 5x on this side. Because what to do to one side, we have to do to the other. So that's how 5x minus 5x, that would just leave us with 5. And over here, we're going to have 6x minus 5x. And 6x minus 5x is just x. So that's how we got x to be equal to 5. Did that clear it up? I made it a little better. All right, awesome. It's good to hear that. Yeah. All right, guys. So good. We've got that going for us. Now let us look at. So that was, which one was that again? Yeah, May, June 2021. So let's look at another one. Let's look at this one. This was January 2016. Zin. And in this question, we are given two functions. F of x is equal to 3 divided by 2x plus 1. And g of x is equal to x squared. And we want to evaluate g of negative half, f of g of negative half, and we're going to want to write an expression for f inverse of x. So let's see what's up with this one. So first, we want to find g of negative half. I wonder if you guys can, I'm going to give you guys that one to do. Who can write in the chat for me what g of negative half would be equal to? Let me see what you got. So remember, g is this one. And what is g of negative half? Let me see what you guys got. No sound I got it, you know. G of negative half. Don't make the negative sign fool you, trouble you or scare you. Let's take it on. G of negative half. What's that? Okay, you realize all of the functions questions, they kind of start out with something like that. So, you know, we want it like, you know, substituting a value or finding an output given the input. So, what is that one? All right, I'm seeing a quarter in the chat. Did anybody else get a quarter? Got the same thing? Oh, seeing some more quarters coming. And yeah, well, let's work it out. So g of x is x squared. So since x is now negative a half, that's going to be negative a half squared. And that's going to be negative 1 times negative 1. That's 1. And 2 times 2, that's 4. Yes. So g of negative half is equal to a quarter. Great job, everybody. Good job. Now, let's go to the next question. It says we want to find f of g of negative half. Now, here's the good thing about how some of these are set up. We already found the g of negative half in the previous question. So we don't need to figure it out again. Because if we think about it, f of g of negative half means that we are putting g of negative half into f, okay? But we already know that g of negative half is a quarter, so f of g of negative half is the same thing as f of a quarter. And now, f of a quarter, so anywhere we see x, we're going to put the quarter, so see the x here. So instead of 3 divided by 2x plus 1, it's going to be 3 divided by 2 times a quarter. What was it, minus 1 or plus 1? Yeah, plus 1.